Lesson 76 is going to deal with volumes of prisms and cylinders, and believe it or not, this is actually a complete repeat of a lesson we've done before. Lesson 42, I just looked it up, was over volume, but we've basically done volume of only rectangular prisms, so we're going to make sure that we've got it down for all prisms and cylinders, but it's the same formula no matter what. Here it is. The volume of a prism is equal to the area of the base times the height of the prism. I use capital B because it's not a like two-dimensional line base that we're trying to find. It's the area of a base, and that'll take some work. And the H is for the height of a prism, also known as the distance between the two bases of a prism. So volume of a prism is the area of the base times the height of the prism. Very simple formula, but we will have to do a little bit of work to find at least the area of the base. Here we go. So this is a prism. Specifically, it's a pup tent that has these dimensions. We're going to sketch the base, and then we're going to find the volume of the tent. Okay. So the base, I better sketch it because I haven't done so already, would be that triangle off the front that is 6 feet high. Sorry for my awful handwriting. It's tough to write on this thing. By 5 feet high. Six for the base and 5 for the height. So volume is area of the base times the height of the prism. Now, the base on this is that triangle I just had shown. So we're going to do, for the area of a triangle, we do 1/2 the base times the height, which in this case is 1/2 of 6 times 5, which is 15. So 15 square feet for the area of the base. So that's the number that we're going to plug into the formula we're actually doing for volume. The area of the base is 15 square feet, and the height of the prism is 7. Now, height is the distance between the bases, so the distance between the two triangles is 7 feet. Okay, now 15 times 7 is 105, and it's cubic feet. We had square feet here and feet here. Square feet times cubic feet, or square feet times feet is cubic feet. All right, let's do it again. Now, this time we have a cylinder, but we can use the same formula for a cylinder because it's really the same thing. We've got a circle on the top and the bottom, and then we got a distance between them. So cylindrical backyard pool, 3 feet high and 20 feet in diameter, holds how many cubic feet of water when full? They're asking us the volume of this pool. Okay, so we're going to use 3.14 for pi, and we're going to round the answer to the nearest 10 cubic feet. Okay, so volume is the area of the base times the height of the prism. So the first thing we've got to do is figure out the area of the base. Now the area of a circle is pi r squared. We're going to use 3.14 for pi, and the radius is 10. So 314 square feet. I mean, this is kind of like scientific notation, guys. It's 3.14 times 10 squared, so just move the decimal place 2 to the right. That's 314, or 3.14 times 100. Okay, don't need a calculator to do that, is what I'm trying to say. All right, so that's the number we're going to plug in for area of the base, and the height is just the distance between the two circles, which is 3. So we get 942 cubic feet. Remember, it's square feet times feet. That's cubic feet. So when we round it, because they want us to round it to the nearest 10 cubic feet, we'll say about 940 cubic feet. Okay. The walls of a garage are 8 feet high, and the peak of the gable roof is 12 feet high. The floor of the garage is a 20-foot square. Sketch the base, then find the volume of the garage. Now, the base on this is actually that front portion right here, because it's the front and the back are identical. It's not the bottom, because that 20 by 20 square foot floor, it's not the same on the top. So the base is going to be this shape right here. So that's made up of a rectangle and a triangle. The rectangle is 20 by 8, 20 foot along the bottom, 8 foot high walls. And that peak right there, we're going to need to know that too. That's 4 feet high. And the reason I know that is because from bottom to top, it's 12 feet. So this 4 plus this 8 makes up that 12. Okay. So we got to find the area of this base because volume is equal to area of the base times the height of the prism. So we're going to find the area of the base by doing the area of that rectangle plus the area of the triangle, or the triangle plus the rectangle. So the triangle is 1/2 base times height, and the rectangle is base times height. The triangle's base is 20, and its height is 4. The rectangle's base is 20 also, and its height is 8. So the area of the triangle is 40 square feet, and the area of the rectangle is 160 square feet. So the area of the base is 200 square feet. So we did all that work just to find the area of this front of the garage. Okay, so for volume now, which is what they want, we're going to do area of the base times the height. So the area of the base we just figured out was 200 square feet. And the height is actually 20 because that's the distance between the two bases. And that is 4,000 cubic feet. It's a lot of work. And now that we know the cubic feet or the volume, lots of air conditioning units or heating units, the size of those units that you need to buy are based on the volume of the space you want to heat or cool. So we need to be able to figure out these computations or do these computations in order to figure out how big of a heater or an air conditioning unit we might need. Okay, now we've got a cylindrical candle that is 15 centimeters high, has a diameter of 8 centimeters. They want us to sketch the shape and then find the volume. Okay, no problem. So I've got a candle that's got an 8 centimeter diameter, and it's 15 centimeters high. So there's my candle. Okay, I'm not going to bother with the wick and the flame and all that stuff, but you guys can feel free to get artistic with it if you want. All right, so we're going to find the volume of this candle. Well, to find the volume of it, the first thing you got to do with volume is you got to know the area of the base. That's that capital B right there. Now, this base is a circle. A circle on top and a circle on bottom. That's why we call it the base. So we're going to go, they want us to leave this in terms of pi. Okay, so we're going to go pi times the radius squared. The radius is 4 because the diameter is 8. Pi times 4 squared, that would be 16 pi. So the area of the base is 16 pi. We'll plug that in, and we're going to multiply that by the height of the prism, which is 15. So all we have to do here is go 16 times 15, and we'll have our answer. That's 240 pi centimeters cubed. Okay, now if we want to know what it is to the nearest cubic centimeter, we could just, multiply 240 times 3.14, and we'd have the answer. But they wanted us to leave this in terms of pi, so we'll call it 240 pi. Pi is an irrational number, so the only way to leave our answer perfect without rounding it is to leave that pi symbol in there. I know it's a little bit new and confusing for you, but we've done it before, but it's been a while. It's a good chance for us to reintroduce that. Got one more example for you. Brenda is putting cubicle boxes that are 6 inches on edge into a larger cubicle box with inside dimensions of 12 inches on the edge. So twice as long for the dimensions. So how many of the smaller boxes will fit into the larger box? Okay, so I'm going to do this mathematically first. I'm going to find the volume of the small, which would be 6 times 6 times 6, which is 216 cubic inches. The volume of the large cube would be 12 times 12 times 12, which is 1,728 cubic inches. Now, if I want to figure out how many small fit in the large, I'll just divide the largest volume by the small's volume, and that'll tell me that it's 8 cubes. So 8 small cubes will fit in 1 large cube. And I'll draw you a little picture here to summarize this. So here's, if I have, a 6 inch by 6 inch by 6 inch cube, that's what it might look like. And I'm going to try and draw a 12 inch cube. So about twice as long, twice as high, and twice as wide. My drawing's not the best here. I'm trying. Sorry. And then I'm going to subdivide this. So something like that. Not perfect, but this is 12 inches long, so it's 6 and 6. So this one red cube right here would be equal to this one red cube down here. Okay, and hopefully you can see the 8 cubes. There's 1, 2, 3, 4 on the front, and there's another 4 on the back. One we can't see any piece of. It's back there in the lower left corner. Back lower left corner. Okay, so that's all I've got for you today on volume. We have done volume before, but today we're dealing with triangular prisms and cylinders, and even looking back on example C, that's a prism that we can't even name, so it's a pentagonal prism, I guess. All right, that's all I got for you today. Have a great day, and we'll see you tomorrow.